So, question number 1. A small business owner, David, is creating a simple encryption program to protect customers' data. He needs to convert the ASCII binary value for the letter N, which is 78, into binary representation for a specific part of the encryption algorithm. Give the binary number for the ASCII binary number 78. So how do we convert the binary numbers to binary? It's a very straightforward method. So you just need to divide the number by 2. Okay, and once you divide the number by 2, you will get even or odd number as the inside the brackets, as you can see here. So if the number is even, you will add a reminder as 0. If the number is odd, like 9, you will add a reminder 1. Okay, so then you need to write the numbers as a binary. So you can write from top to bottom. So starting from this one to here. So this is the first number. So here is our answer. So 1 0 1 0 0 triple 1 0. So we need to show the 8-bit number. That's why we have added one extra 0 here. Okay, so that's how you convert the binary numbers to binary numbers. Okay, I hope you got the idea. Question number 2. You have a number here. This number can be stored as 2's complement integer. Convert the 2's complement integer, this number, to binary and show all your working. So how do we convert a binary number which is in 2's complement? So simple. Okay, so first you need to remember that the most significant bit is 128, minus 128. So what does it mean by the most significant bit? So in this case, this number, this 1, is our most significant bit. Okay, so first now we need to add the powers of 2, 1, 2, 4, 8, 16, 32, 64 and minus 128. Next step, you know that we need to add the numbers where we see the 1 underneath them. For example, 32, 2 and 1. So let's add those positive numbers first. 32 plus 2 plus 1 is 35, and then we need to add minus 128. So minus 128 plus 35, so the answer will be minus 93. So this number, this 2's complement number, is equal to minus 93. Let's go to the question number 3. The binary number minus 32 is stored as 2's complement integer. Calculate the 2's complement integer that would be stored. So how do we convert the binary numbers or negative binary numbers to binary using the 2's complement? So step number 1, you just ignore the sign minus here and convert the 32 into binary. Okay, so because we need to convert as 8-bit binary number, that's why we have to add the powers till 8. So 1, 2, 4, 8, 16, 32, 64, 128, and the binary of 32 is what? 1 0 0 0 0, all zeros. First, then we got the binary of 32. Next step is to flip the bits. So 1 will become 0 and 0 will become 1. So as you can see here, this 0 became 1, 0 became 1, 1, and 1 became 0. This is the second step. Step number 3 is add 1. So now we need to add 1 to this number, this flipped number. Okay, so let's see what is the answer. So 1 plus 1 is 0, 1 carry, 1 plus 1 again 0, 1 carry, 1 plus 1 again 0, 1 carry, 1 plus 1 again 0, 1 carry, 1 plus 1 0, and carry. So now 1 plus 0 is what? 1. Then 1 and 1. So this is our answer. 1 1 1 0 0 0 and 0. Question number 4. Convert A to F to binary. So what is A to F? A to F is a hexadecimal number, and we need to convert this hexadecimal number into binary. First of all, you need to know what are the hexadecimal numbers. So here you can see on the top we have binary numbers from 0 to 15, and underneath we have the hexadecimal numbers. So hexadecimal numbers and binary numbers are same until the number 9, but in hexadecimal we don't have the number 10. We represent the number 10 as A, 11 as B, 12 as C, 13 as D, 14 as E, and 15 as F. And one more thing that you need to know is one hexadecimal number is equal to 4 bits, right? So here you can see, so first we write the first number, which is A, then 2, then F, and we know there's every hexadecimal number is 4 bits, so that's why we have written the powers of 2, 1, 2, 4, 8. So these are the 4 powers. So what is the binary of A? A is what? A is 10 in binary. So what is the binary of 10? It's 1010. Now let's see the next number, which is 2. 2, what is the binary of 2? Is 0010. Next number is f. F is equal to 15. So what is the binary of 15? 15 binary is 1111. So that's how you convert the hexadecimal numbers into binary. Question number 5. This is your answer. Question number 5. Two binary integers, first this number and this numbers, are added together. Add the binary integers using binary addition and show your answer in binary. So now we need to add those two numbers together using the binary additions. I hope you know the rules for adding two binary numbers. So let me review for you. First rule is 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, and 1 is carry. Okay, so let's keep in mind these rules and let's apply them on this number. So first is 0 plus 0 is what? 0. 0 plus 1 is 1. 0 plus 1 again is 1. 0 plus 0 is 0. 1 plus 0 is 0. 1 plus 1. So what is the answer? Is 0 and 1 carry. Okay. Now again 1 plus 0 is what? 1. And then 1 plus 1 is what? 0 and 1 carry here. 1 plus 0 is 1. That's our answer. Question number 6. Two binary numbers are added by a computer and an overflow error occurs. Explain why the overflow error occurred. So what is the overflow error? So here is the definition of the overflow error. An overflow error occurs when the result of the binary addition is too large to be stored in the allocated number of bits, causing the loss of the most significant bits. So as we know, we store the numbers in the registers, and if we have, let's say, we have 8-bit register and we try to add two numbers and their sum is larger than 255 or 256, then we cannot store that number in an 8-bit register. So that is why the overflow error occurs. Question number 7. The binary number 1010011 is stored in RAM or random access memory. Give the 8-bit binary number that will be stored after the shift has taken place. A logical left shift of 3 places is performed on the binary number. So now we know two information. First one is that it's a logical left shift, and how many places? 3 places. I'm going to show you a very easy trick to solve these type of questions, the shift questions. Okay. So step number 1, you have a number here. Okay. Step number 2, you just delete the 3 bits or whatever bits they are mentioned in the question. So it says left shift, so we remove 3 bits from the left sides, and the last option is we add 3 zeros on the right side. Okay, so you add just 3 zeros and this is your answer. You can pause, you can look at this one, how it's going, and then you can just memorize these tricks. Step number 1, you remove the bits, 3 or 4, whatever is in the question, from the left or the right side, and then add the zeros on the other side. Okay. Let's see the next question. A value is stored as binary number in a register. So this is the value. A logical right shift of 3 places is performed on the binary number. Complete the binary register to show its content after this logical right shift. So this time we have to do the right shift, and how many places? 3 places. So we're going to apply the same trick. We're going to first remove the 3 numbers from the right side. Okay. Then we need to add 3 zeros on the left side, and that's our answer. Okay. Question number 9. Give 2 reasons why a programmer may use hexadecimal to represent binary numbers. Okay. So now we need to give the reasons why a programmer may use hexadecimal instead of using the binary. So the first reason is more compact and shorter representation. As we know that one hexadecimal number is equal to 4 bits. Instead of writing 4 binary numbers, we can just write one hexadecimal number, so it takes less space, okay, or it's shorter. Next one is easy conversion to and from the binary, and it's easy to convert a binary number to hexadecimal and the hexadecimal number to a binary number. Question number 10. The binary number stored for an address and is this number, this big number, convert the binary number to hexadecimal. So this time we have to convert a binary number to hexadecimal. Again, I'm showing you the table. Okay, so binary numbers and we have the hexadecimal numbers. So now I'm again reminding you that each hexadecimal number is equal to 4 bits. So how we approach this problem? So step number 1, you split the number into group of 4 bits. So this is the whole number. First 4 bits, comma, next 4 bits, and the next 4 bits. Then we convert each group separately to the binary. Okay, so here you can see the first group 1, 2, 4, 8, 0, 0, 0, 1, which is what? 1 in the binary. So 1 is 1. Okay, next one is what? Next one is 8 plus 1, which is 9, right? And the last one is what? Let's convert this one, is 11. 11 is what? 11 in the hexadecimal is B. So our answer is 1, 9, and B. Okay. Question number 11. Identify 2 ways that hexadecimal is used in computer science. So now you need to tell where we use the hexadecimal in computer science. There's so many places where we use hexadecimal in computer science. For example, HTML color codes. Okay, RGB values are usually in the hexadecimal. Number 2, URL. URL, I hope you know the URL, Uniform Resource Locator. It's a link to a specific content on World Wide Web. Memory dumps, IP addresses, IPv6, okay, not IPv4. MAC addresses, assembly language, error codes, and messages. Okay, so and the last one is ASCII and Unicode also uses the hexadecimal. You can pause, you can take a screenshot or whatever you want. Okay. Question number 12. The binary number is measured as a byte because it has 8 bits. State how many bytes there are in a KB byte. So here is the table. So 1 bit is either 0 or 1. 4 bit is equal to 1 nibble. 8 bits equal to 1 byte. 1024 bytes equal to 1 KB byte. 1024 KB byte is equal to 1 megabyte. 1024 megabyte is equal to 1 KB byte. And 1024 GB byte is equal to 1 TB byte. So the question is asking us how many bytes are there in a KB byte. So we know it's 1024 bytes are in 1 KB byte. Okay. Question number 13. A new computer comes with the primary and the secondary storage. Data storage is measured using the binary demonstrations. Denominations. Complete each conversion. So I'll give you some numbers and you need to convert them to different units. First one, 8 bytes equal to dash nibbles. Number 2, 512 KB bytes equal to dash megabytes. Number 3, 4 GB byte equal to dash megabytes. Number 4, 1 exabyte equal to dash petabyte. First one, for 8 byte is equal to what? Is 16 nibbles because 1 nibble is equal to 4 bits. 522 KB byte is equal to 0.5 megabyte. 4 GB byte is equal to 4096 megabyte, and 1 exabyte is equal to 1024 petabyte. Question number 14. A museum archivist needs to store a large collection of historical documents as text files to save storage space. They decided to use lossless compression. State what effect this has on the file size of the document. So we use the compression to reduce the file size, right? We have two methods for compressing the data. One is called the lossy compression. The other one is called the lossless compression. If we use the lossy compression, we lose some data, and that's how we reduce the file size. If we use the lossless compression, we do not lose any data, but still the file size is compressed or reduced. The file size is reduced. So what is the answer for this question? So why? First one is reduces the file size. So compression will reduce the file size, make the file size smaller, and decreases the amount of storage needed. So these are some reasons that you can write. Okay. So since this question is 1 mark question, you can just write one of those in the answer. Question number 15. A software company needs to archive old project documentation. They want to use lossless compression to reduce the file size without losing any data. Describe how lossless compression compresses a text file. So now we need to see how the lossless compression compresses a text file. As we know that in the lossless compression, we do not lose any data, right? So one method of lossless compression is called the RLE, or run length encoding. Okay. So here, lossless compression reduces the file size without losing any data. It identifies pattern or repeated sequence of data. It stores these pattern or sequence using a shorter representation, for example, indexes or codes. When the file is decompressed, the original data is perfectly reconstructed. And the last point is an example is run length encoding. Run length encoding method is illustrated in our book, so you can go and see how this method compresses the data. Okay, so this method replaces the repeated sequence of the same character with the count and the character. Question number 16. A text file can be compressed using lossless compression. Give 2 reasons why the text file may have been compressed. I hope you know the answer. To reduce the storage space required to store the file, to speed up the transmission, for example, faster download or faster upload. Okay, and then to reduce the bandwidth usage. So when you transmit the data, you will require less bandwidth if the file is compressed. To allow more files to be stored. So if the file is compressed, the size is small. So if the size is small, it takes less storage, and then you can store more data on the storage device. Question number 17. Georgia compresses photographs to store them on the USB flash memory drive. It is important that the compression does not affect the quality of the photographs in any way. State which type of compression is most suitable and justify your answer. So now we don't want to lose the data, right? So that's why we should use which compression? We should use the lossless compression. So the most suitable type of compression is lossless compression in this case. Lossless compression does not lose any data during the compression process. The original image can be perfectly reconstructed when the file is uncompressed. Question number 18. Tina uses a microphone to record a welcome message for her website. She wants to compress the recording to make sure that the file is small as possible for the website. Identify which type of compression she should use and describe how this would compress the file for the website. So number 1, a type of compression, they should use the lossy compression. Lossy compression reduces the file size by permanently removing some of the data. It identifies and discards the less important parts of the audio file. For example, the audio that the human ears cannot hear, or some noise from the file. And this results in smaller file size, but some audio quality is lost. This is acceptable for a welcome message on a website where the file size is more important than the perfect audio fidelity. Question number 19. Tina uses a microphone to record a welcome message for her website. Give 2 benefits of compressing the file for the website. So what are the 2 benefits for compressing the file? So again, it reduces the storage space required on the web server, decreases the download time for the user visiting the website, reduces the bandwidth usage, and allow more files to be stored on the server. Question number 20. Sammy creates video for the finance company website that give customers advice about their finances. He uses lossy compression to reduce the file size of the video for the website. Gave 3 ways that the lossy compression can reduce the file size of the video. So now we're talking about the lossy compression. Okay, so lossy compression may reduce the video size by reducing the color depth, reducing the frame rate, reducing the resolution of the video, and removing non-essential data, and identifying and removing the redundant data. Okay, so this question is 3-mark question, so you can just write any 3 points and you can, yeah, you're good to go. Let me go and see if you have any question, so I can answer your question. If no, then we can continue. Okay, let's continue. Question number 21. Audrey wants to send a sound file to a friend as an email attachment. The original sound file, file sound is too large to send as an attachment. State how Audrey can reduce the size of the sound file. Okay, so same thing, we need to reduce the sound of a file size. This means we need to use some compression method. So what compression method? We have 2 options only. We have lossy compression and lossless compression. So for this case, we use the lossy compression to reduce the sound, image and the video file size. So for the sound, image and the videos, we usually use the lossy compression. Okay, only we don't use the lossy compression when they say we don't want to lose the quality. Okay, so in this case we will not use the lossy compression, we use the lossless, but any other situations we just use the lossy compression. Question number 22. A musician has recorded a song and wants to email it to a friend. However, the uncompressed audio file is too large to send easily. Explain how lossy compression reduces the sound file size, making it easier to email. So lossy compression will permanently remove some of the data from the file, remove the sound that are outside of the human hearing range, and reduce the sampling rate, reducing the bit depth resolution, and this make the file size smaller but reduces the quality of the sound. So these are the different ways. It can be the lossy compression can be used to reduce the file size. Question number 23. Explain the difference between a lossy and lossless compression, lossless file format. So you can see lossy compression and the lossless compression. Lossy compression, some data is lost during the compression. In the lossless compression, no data is lost during the compression. In lossy compression, a reduced file size is more than lossless compression, and the lossless compression can be restored to the original quality. Okay, but here we cannot restore to original quality. Lossy compression cannot be restored to the original quality, and here you can see the larger file size compared to the lossy compression for the small for the same data. Question number 24. A wildlife photographer stores their digital images on a computer. Complete the table by identifying each term about images. The first term is the smallest component of the image. So what is this term? It's called the pixel. The number of pixel wide by the number of pixel high. What is this thing? It's called the resolution. It's the definition of the resolution. Let's move to the question number 25. Identify 3 different file formats that can be used to store a digital photograph. I think you know this one: JPEG, PNG, and GIF or GIF. Okay. Question number 26. Identify 3 different file formats that can be used to store a digital sound recording. So MP3, WAV, and AAC. Okay. Question number 27. Jessica wants to store a large number of small thumbnail images on a USB flash memory drive. Each thumbnail image is 16-bit color and is 100 pixel wide and 100 pixel high. So what is this thing? 100 pixel wide and 100 pixel high is the resolution. Okay. She has 5 MB of storage space available on her USB flash memory drive. Calculate how many images she can store in the 5 MB of storage space. So let's do it step by step. Step number 1, the size in the bits per image is what? 100 multiplied by 100 multiplied by 16. Okay, so you need to multiply all those numbers, 100, 100 and 16. Okay, and you got the answer in bits. So this is the bits, 160 000 bits. Next is we need to convert this to bytes, right? The size in the bytes per image is what? We just divide the number into with the 8 and you will get the bytes. So this much bits is equal to 20,000 bytes. Next, we need to calculate the total storage in byte. So how much total storage it will take? Okay, so 5 MB is equal to what? 5 multiplied by this number, and we got this much byte. And then we divide this number by 20, and then we know the number of images that can be stored in the USB. Okay. Question number 28. A student has a portable tablet computer. Identify input device that could be built into the portable tablet computer. Please see the word built into. Okay, it's not the external device. So first one could be the touch screen, microphone, a button, a camera, a biometric device such as the facial recognition that sensor or that fingerprint sensor, etc. Okay. Question number 29. Julia input personal data into her computer. She stores 3 copies of the data using a hard disk drive, a solid state drive and a USB flash memory drive. Identify 3 devices Julia can use to input personal data into her computer. So this time it's not asking for some built-in, so you can give any input device. Okay, so a keyboard, a mouse, a scanner, a microphone, a webcam, etc. Question 30. A bus station has a ticket machine. A customer can use the ticket machine to select and pay for their ticket. One input device built into the ticket machine is a touch screen. Identify 2 other input devices that could be built into the ticket machine. So again, built into. So let's see, we can say keyboard, a keypad, a trackpad, a trackball, microphone, sensor, a button, a barcode, QR code, scanner or reader, and the last one could be a webcam or a digital camera. Let's go to the question number 31. The ticket machine has a help icon that a user can touch to contact customer support. The ticket machine has an output device that allows the user to hear the customer support person. Identify an output device that would be used for this purpose. So that could be speaker or headphones. Question 32. A museum is creating an interactive information point for visitors. Identify one output device that could be built into information point. Give an example of how that device would be used in this context. So for example, display screen or monitor or a touch screen could be used to see a shop location. A speaker or a headphone could be used to hear where a shop is located. A printer, for example, to get a hard copy of shop information. LED or LED light, example, to indicate where a shop is on the map. Question number 33. A library has a self-checkout system that allows customers to register books that they want. The microprocessor also uses output to control the system. gave 3 examples of output that the microprocessor is likely to use. Number 1, a sound to a speaker, text to a screen, data to a printer, image to a projector. Question number 34. A shopping mall has an information point. Visitors can use it to find out which shops are in the mall and where they are located. Identify one input device that could be built into the information point. Give an example of how the device would be used. So, keyboard to type in a shop name, a mouse to click on a shop, a microphone to speak the shop name as a voice command, touchscreen to select a shop, barcode scanner to scan a barcode for a voucher, a sensor to detect when a person walks past, a webcam to video call for assistant. Okay, so it's a 2-mark question, so you can just choose any 2 devices from this answer and write. Question number 35. Which statement is correct about RAM? RAM stands for random access memory. It's a type of primary storage. A primary storage is a type of storage which is directly accessible to the CPU. Let's read the option A. It is not directly accessible by the central processing unit or CPU. It is non-volatile storage. It stores data that is currently in use. It stores the bootloader. So I hope you have guessed the correct answer, and the correct answer is option C. It stores data that is currently in use. Question 36. 5 components are shown. Show whether each component is an example of input, output, or storage. The first component is actuator. So each actuator is what is an example of output device. Next component is a register. A register is a type of storage. Okay, it stores address or data. Okay, so for example, PC is a register that stores the address of the next instruction. MDR is a register that stores the data from the RAM. Sensor is an input device. Mouse is an input device. DVD or digital versatile disk is a storage device. Question number 37. ROM is a type of primary storage. State the characteristic of ROM that makes it a type of primary storage. So a primary storage is a type of storage that is directly accessible by the CPU or to the CPU. So RAM, ROM, they are both primary storage and they are both directly accessible by the CPU, which means the CPU can directly read and write data from the RAM and the ROM. Okay, next question, question number 38. The photographer decides to purchase a solid state storage device to back up their images. Complete the description of solid state storage. Okay, number 1, solid state storage is dash. This means that the data is not lost when the power is turned off. So we have 2 types of storage. One is called the volatile storage. The other one is called the non-volatile storage. If a storage is volatile, it means when there is no power, the data will be lost. Example, RAM, random access memory, is a volatile storage. But any other storage, for example, SSD, HDD, USB flash, okay, SD card, any other, they are non-volatile. Okay, so when you connect them with the computer, okay, then you can write the data onto those devices, and when you unplug them, okay, the data still remain on them. Number 2, solid state storage is made of dash that are laid out in a dash. So it is made up of the transistor that are laid out in a grid. Okay. Gates are used to control the flow of electrons through the transistors. This changes the data in the transistors from 1 to 0 or from 0 to 1. Okay, question number 39. 5 statements are shown about random access memory or RAM. An internal solid state drive SSD and a USB flash memory drive. Tick to show which statement apply to each component. Some statement may apply to more than one components. Okay, so statement number 1, it's the type of primary storage. So which one is primary storage? It's RAM. Statement number 2, it's volatile. So which one is volatile from those 3 storage? Is RAM. What is meant by the volatile? It loses the data when there is no power. Statement number 3, it uses NAND and NOR technology. So which one uses NAND and NOR technology? It's internal SSD and the USB flash memory drive. Okay. Next, it does not have any moving parts. So RAM does not have any moving parts, internal SSD does not have any moving part, and USB flash memory drive does not have any moving parts. Last, it is not directly connected to the CPU. So we know it's SSD and the USB flash memory drive. So these two are secondary storage. So that is why they are not directly connected to the CPU, but the RAM is directly connected to the CPU. Question number 40. A photographer needs to store a large number of high-resolution images. Give 2 examples of suitable secondary storage devices that they could use. So now you need to give me the names of secondary storage devices. Okay, so secondary storage devices are hard disk drive, solid state drive, SSD, USB flash memory, DVD, CD, and Blu-ray disc. Okay. Next, question number 41. A graphic designer is working on a large image file using photo editing software. Explain why their computer needs RAM to efficiently handle this task. So to store data temporarily, we need the RAM. To store data currently in use, we need the RAM. To store software currently in use, for example, Photoshop or any software he's using, we use RAM. Data can be accessed faster than the secondary storage. So when it's used editing the file, okay, so if it's stored in the hard disk, it's slow. So CPU work very fast. To speed up the fetch stage or of the fetch, decode, execute cycle. Okay, so you can just write any 2 or 3 in the answer. Question number 42. The computer in the finance company use both primary and secondary storage. Give 1 example of primary storage. So it's a 1-mark question. You just need to give 1 example. But here you have RAM, random access memory, is an example of primary storage. ROM, read-only memory, is an example of what? Primary storage. And you have cache memory is also an example of the primary storage. Question number 43. Random access memory RAM is an example of primary storage. Gave 3 examples of data that is commonly stored in the RAM. This question is very important, and here I have a hack for you to memorize the answer. If the same question came in the exam, you can easily answer. So you just need to remember the word currently running. Okay, currently running data, currently running instructions, currently running parts of operating system, currently running softwares, currently running utility software. Okay, so just remember everything that is currently running, it's inside the RAM. Okay, next question number 44. A user has both system software and application software installed on their computer. State which component in the computer would store both type of softwares when the power is turned off. So we know there are 2 types of storage. One is called the volatile storage, or the other one is called the non-volatile storage. Volatile storage is the type of storage that only store the data when it has power. Example, RAM. And any other storage is what? Is non-volatile. So here you can see hard disk drive is non-volatile, solid state drive is non-volatile, and any non-volatile memory. Okay, and secondary, I think it's a mistake here. So just yeah, secondary storage devices, for example, all the secondary storage devices, most of the secondary storage devices are non-volatile. For example, CD, DVD, Blu-ray disc. Okay, so all of these are the non-volatile. Okay, question 45. The self-checkout system uses 2 types of primary storage. Give 2 types of secondary storage that would be used in the system. So now you need to tell that 2 types of secondary storage that would be used in the system. So now let's talk. Number one is the hard disk drive, or HDD. Number two is solid state drive, SSD, and then you can say Blu-ray disc. Okay, these are the different types. Next question. A small business owner, Sarah, needs to store customers' data, sales record, and accounting information for long-term access and backup. Describe the purpose of secondary storage in Sarah's business. So Sarah can use can store the data permanently on the secondary storage. Okay. To store data that is not currently required by the CPU, to store data to transfer it to another computer. For example, she can use the external secondary storage devices such as USB flash memory or CD or DVD to transfer file from one computer to the other. Question number 47. A student has a computer that has a CPU. Describe the role of the CPU in the computer. This is a very important concept, or you can say usually it's in the exam. Okay, so what is the role of a CPU? Is to perform, to process instruction or data, or number two, you can say to run, fetch, decode, execute cycle. Okay, either one or two, both okay. Either you remember the first one, the to process instruction or data, or you can say to run, fetch, decode, execute cycle. Question number 48. The CPU contained register. State the purpose of a register. So what is a register? Register is inside the CPU. It stores the address, data, instruction, etc. So to temporarily store data, instruction, or address, or to allow immediate access to data during the fetch, decode, execute cycle. Question number 49. Give 3 registers that are built into the CPU. So we know some registers that are built into the CPU. For example, MAR or memory address register, MDR or memory data register. Then you have the ACC or accumulator register. Then you have the PC, like program counter register. And the last one is CIR or the current instruction register. Make sure you know the name of those registers and their abbreviations. Okay. Question 50. Complete the following statement about the fetch, decode, execute cycle. So here we have the long statement. Okay. So first one is an instruction is dash from RAM into the CPU where it's temporarily stored in the dash. So instruction is fetched from the RAM into the CPU where it's temporarily stored in the register MDR or memory data register. The instruction is then sent along dash to this control unit or the CU to be dash. So it's the MDR uses the data bus to send the instruction to the control unit to be what we do in the control unit, to decode the instruction, right? To decode, to be decoded. The dash will be then perform any dash and logical operation that are required to dash the instruction. The ALU or arithmetic logic unit will then perform any calculation and logical operation that are required to do what? To execute the instruction. So I think 50 questions are enough today. Tomorrow I'll back with some new questions. So make sure you watch the video. I'll upload the video, and yeah, see you tomorrow. Bye.